All right. Today, we start with this chapter 7.6. We have trigonometric form of complex numbers. It sounds ridiculous. Kind of is ridiculous to some degree. Um, it's hard to see why it matters and why we're going to use it. But it starts with plotting complex numbers. And so I have a daughter. Her name is Tenley. Tenley's in 2nd grade. Tenley, if you're watching this video, you should go do your reading instead. They've pulled him up a couple times just for jokes, like, hey, that's my dad on YouTube. He sounds stupid. Well, tell him if you want to see something stupid, look in the mirror. Ha ha ha! Take that. Yeah, right. There you go. Wow. Yeah. Ouch. It's my daughter. I can say what I want. All right. Here we go. So if I ask Tenley to go ahead and plot a number on a number line, hi there, Sam. If I asked her to plot a number on the number line, she might take a look at this, and I think that's what you need. And, if I say, well, Tenley, plot the number 1 on a number line, that'll be pretty easy, right? Or I say, plot the number -1/2. That might be more difficult, but she might say, plot it right there, hopefully, and I do, really good job. If I told Tenley to plot -√3, she'd have no idea. She's like, what's that thing, Dad? And I'm like, well, it's the square root, idiot. Come on. How do you use it? But, the fact is that you guys know it's about -1.73, and you would plot it right about here, right? Okay. And so you would hopefully get that right. But plotting real numbers after a while, like that could get pretty boring, right? Like if I gave you an assignment, hey, let's plot real numbers. You'd be like, okay, no big deal. Well, how do we plot a number like this? 4 plus 2i. Where does that go on this number line? And the fact is that it doesn't go on this number line because this is the real number line. What we have to do is we have to add another number line to it that goes up and down that's called the imaginary one. So let's put this in our notes. Complex numbers a plus bi. Your real axis is where the a value will go. So we call that the real axis, just like we've seen before. Real numbers get plotted there. And then the imaginary axis is going to be whatever b is. And we make that the vertical one. Together, they make what we call the complex plane. So your first goal is to be able to plot these numbers, just like we would plot something on a number line. Say z sub 1 is equal to 2 plus 4i. Well, when we plot it, we just go 2 units to the right, and we go 4 units up. And you plot it, but you do draw a segment that goes from the point to the origin. You do draw that. Okay, I'm not going to itch that for you. So. Okay, all right. Any question how we did that? Look at the next one. It says plot, z sub 2. Well, z sub 2 is -1 minus 5i. So that means I'm going to go back 1 and down 5. So if I go back 1 and down 5, that's what that plot looks like. Maybe you have a fungus. We can do all sorts of operations. You could do z sub 1 plus z sub 2. How do you think I do that? I add them together. And 2 and -1 make 1, and 4i and -5i make -i. So 1 minus I, which quadrant is that going to place me in? The 4th quadrant. So I go over 1 and down 1, and that's the plot of z sub 1 plus z sub 2. How are we feeling about that? Yes, it definitely gets more challenging. Okay. The next one, negative z sub 1. It says z sub I. I meant z sub 1. What do you think I do to compute negative z sub 1? Yeah, take z sub 1 and multiply by. Yeah, and I get negative 2 minus 4i. Oh. So when we plot that, I go back 2, I go down 4. That's what I've got. What do you notice about that compared to the original one? Yeah, it's in the exact opposite direction, isn't it? Yeah. Let's do 1/2 z sub 1. What do you think I do to generate 1/2 z sub 1? Yep, divide by 2 or multiply by half, and I get 1 plus 2i. If I graph 1 plus 2i, go over 1 and up 2. How does that compare to my original graph? Yeah, it's exactly half. What do you think? Could you do this on the test? Take a test on this right now. Noah says step up if I make it this easy. Well, let's learn a second skill that we need. One thing we like to do with numbers is we like to find the absolute values. So for example, if I say, what's the absolute value of 1, you say, and the absolute value of negative 1/2 is, and the absolute value of negative root of 3 is. How do you determine absolute value? Like if you were trying to explain to Tenley, my distance from 0. Yeah. Just make it positive. Okay. All right. Yep. You right. But if she said why, you would say, well, because that's how far it is from 0 on the number line, right? And it should be confused by then, right? But we get the idea. So it's about how far it is from 0 on the number line. So you're going to get smarter right now. Are you ready to get smarter? Like it's going to happen for you. Something's going to click. The absolute value of a complex number. Well, if we said that the absolute value of a real number is its distance from 0, then the absolute value of a complex number should be what? Its distance from the origin. See that? So let's look at that first one. Let's look at 2 plus 4i. If you wanted to find how far this was from the origin, what would you do? Distance formula. Where does the distance formula come from? The Pythagorean theorem. Couldn't we just say, well, it's over 2 and it's up 4, so 2 squared plus 4 squared is that squared, right? Exactly, and that's why the complex numbers, you're like, why are we talking about complex numbers? I thought we were doing trigonometry. Well, they tie right into trigonometry because it's based around the Pythagorean theorem. So the definition of the modulus is the distance from the origin. Or if you were to say the absolute value of a plus bi, which we say is the absolute value of z, we use z to represent the complex number set. Okay, the absolute value of z is equal to, we'd say the square root of a squared plus b squared. So the example says find the modulus. The modulus is the absolute value. That's I don't know where modulus comes from. I'll have to look up where that word originates. But modulus of z sub 1, well, if z sub 1 is equal to 2 plus 4i, then the absolute value of z sub 1 is equal to, how do I compute that? Square root of 2 squared plus 4 squared. Well, what's 2 squared? 4 squared. 4 plus 16, 20, and square root of 20, 2 roots of 5. So the absolute value of 2 plus 4i is 2 roots of 5. That's how we define that. You try the next one on your own. Try to do z sub 2, which is negative 1 minus 5i. Find that absolute value and see what you get. the root of 26. Very good. Not too bad, huh? Just recall that you do not square the I. The I is not part of the calculation. You use A, and B is the number in front of I. Everybody got that? So we're going to let you do a couple problems on your assignment right now, but we do have to get through this part before we end today. Okay. So I'm going to pause. Wow. YouTube, I totally forgot to press record here. Man, yeah. Wow, you're going to want to watch a video from last year. Sorry, Alexis. You're the one that was going to want to watch this. Yeah, check the one from last year.
Did you finish that letter?
Yes. So I sent you an email. I said for sure have it by tomorrow.
Okay.
That works for you, right?
Yeah, that works.
Okay. I'm going to print it off. I always put them in envelopes. So it's going to lacrosse. Is this correct?
No, these are for the local schools. The one that